into a new massing project to show you guys how to do that. So I'm going to just go ahead and make a copy of my level 1 floor plan, and I think I'm just going to set it about 5 feet above my first floor. It'll make things a little bit smoother. And I'm going to draw some reference lines, rectangular reference. I feel like I'm starting into part 2, but I'm really not. Yes? That's a good question. It's in the back. Make its way forward. Actually, let's do... Alright, so I changed mine to model lines just to make it a little less confusing with all those reference planes associated with the reference lines. So I have this rectangle, and I'm going to copy it up, copy to the clipboard, and align it to my level 2 so that, well, that's a really big one. It's going to be a really I need to just quickly make this thing. Well, I've got 2 of those in there. What's going on here? Good man, good man. I just want to reduce the size of this guy. To be like 10 feet by 10 feet, I think. That's fun, that dimension's not working. Why is nothing working today? There we go. Now I'm going to copy my 10 foot by 10 foot up to my second level so that it looks more like a pyramid when I create it. So I've got these 2 model line squares, and we're going to start setting some points up. We're going to use this endpoint. Wait a second. Backing up. Reference model lines. Reference lines. And we're going to snap from one endpoint to, I need to turn my 3D snapping on for this to work, to the midpoint of this rectangle on the second story, and back down to the first story, and basically connecting those dots so that I have a triangle form on this side with 3 reference lines defining it.
Are you trying to 3D
In your Modify Options tab here at the bottom of the ribbon, when you have the tool selected, should be a 3D snapping option there. And so now I need to draw similar triangles on this side. Doesn't matter which side, but definitely the one perpendicular, right, to this face. I missed that snap point. there to the midpoint. So now that I hover over that, those reference lines, all three light up. So I can create a solid form out of that, and by grabbing this red arrow, I can move this over and can highlight those reference lines and create a void form, not a solid form but a void form, and choose the extruded form over the panel form. And then drag that through, and initially it doesn't cut it, but when you click off the command, and it didn't cut it there either. So what we can do is use the cut geometry tool and physically cut it ourselves by picking the geometry that you want to cut into and then picking the geometry that's cutting through. And then we're going to select those three reference lines and create a void form, extrusion, and we're going to drag that one across. And that one didn't cut either. So I'm going to use the cut tool.
Can you go beyond that last edge?
You can go beyond the edge. As long as the void is cutting through the object, it doesn't matter where the start and stop point of the void is itself. Yeah. So for instance, take that back. It's not going to let me change that after I dragged it. Yeah. But no, it doesn't matter, to answer your question. So that's how you make the pyramid. Is everybody on board with that?
So you just went up and click the cut tool and click both objects?
Yeah, it didn't cut initially through the triangle, so I forced it to by using the cut geometry tool. By saying, no, I want you to cut this. Sometimes it acts funny and doesn't do it automatically. Okay. So with that, let's jump into making our three-dimensional parametric rectangle that flexes. I'm going to go ahead and delete this object, and we're already in, or I'm already in the massing family. If you guys want to open up, not everybody's in this project environment, go ahead and open up a mass family project environment. I need to walk through that. Go to the View tab, back to our reference files, and click on New Conceptual Mass. New Mass. Okay, so it's pretty important to, or in best practice, is to, when you're doing parametrics, is you want to dimension to your reference planes and reference lines, and allow those to actually flex instead of like grabbing your model line. And that was kind of some issues that came up in homework, the model or the wall tool when we did the 2D parametric flexing profile. Some people didn't quite get the dimension tool to lock to the reference lines. They tried to, they locked it to the model line itself, and so when that happens, sometimes it flexes, but it starts to move around on the screen because it's not locked down in the location where you want it to be locked down to. And so it's pretty important in this moving forward to just think about that and say, what am I dimensioning to? I want to dimension to the reference lines and the reference planes and have those move in relationship to each other, and then any model line work that you create is then locked to those reference planes and reference lines. Does that make some sense? So that stuff stays in the same place on the screen. So with that, we're going to choose reference lines and we're going to make a rectangle, and I'm going to unclick my 3D snapping at the moment, and we just want to draw on our first floor plan, and I'm just going to drag out a rectangle. And it doesn't really matter how big it is right now or where it's necessarily placed, because we're going to define where it's placed based upon dimensions. And so now that I have that there, I'm going to go ahead and grab my dimension tool, and I'm going to dimension this reference line to the center reference plane, and then again to the opposite reference line. And I'm going to click out of the command, and I'm going to set the equal button on those two dimensions so that they're always equal from each other. And I'm going to do that with the opposite reference lines as well. I'm going to set those equal. So now this thing is defined in space. It's centered on this center point, and it's not going to go anywhere. It's always going to stay there. You know, when we flex this thing, that center point will always be the center point of the object. Okay? And so now we're going to set another dimension that will define this length, and a dimension that defines this width, or vice versa, however you want to think about it. And we're going to exit out of the command, and let's just grab, highlight and select this dimension here, and you'll notice that we have in our options tab this label that we got familiar with the 2D reference profile that we made parametric. We can go ahead and add a parameter to that, and we're just going to call this W for width. Say OK. And I'm going to do the same on this side, defining a parameter. I'm going to add a new parameter, and we're going to call this L for length. Say OK. And just as we, in our 2D profile, we want to make sure that this thing flexes the way that we want it to flex. So I'm going to open up the family types, and I'm going to change these dimensions to 100 feet and hit apply. And they both changed, and they changed correctly, as in it's correctly spaced. It's not moving around the screen. So at this point, now that we know that these two parameters function, A, we should save it, And then B, we can start to create an extrusion so that the extrusion now will flex length and width. So I'm not going to save my model, but I would save yours just in case the file gets corrupted or your computer crashes. It's just kind of best practice to do that every time you define a parameter so that you're not having to work backwards if your computer crashes. Also, if it doesn't work, you figure out why it doesn't work before you move forward. And so if you move forward with a bunch of parameters and the thing doesn't flex in one direction in a complicated part, you're not going to really know which part's not working correctly, and you have to kind of intuitively go backwards, and it takes a lot of time, and it's just best practice to make sure each one's working before you actually take the next step. If that makes any sense. So with that, we're going to highlight all 4 reference planes, and we're going to create a solid form, and we're going to create an extruded rectangle. And before you click on anything, you'll see that this dimension line pops up for the height. And if we scroll in, there's a little dimension tool here. If you select it, it makes that dimension permanent. And so once we do that, we can select that dimension and define another parameter as being the height of this object. Let's say OK. And so again, let's check to see if this works. Say 100 feet, press apply. That's working. And if just for the fun of it, let's just change them all to 50 feet. Okay, so the whole thing, it shrinks in all directions down to 50 feet. So it's flexing the way that we want it to flex. Press OK. At this point, I don't know if anybody's looked at the parametric mass for part 2, but there's a hole in the middle of it that cuts through the entire object. And the goal for that for us is to create that hole and have that flex as well, getting bigger and smaller with our rectangle. Do we need to take like a few minute break to get everybody on this page that this thing's flexing?
Yeah.
Okay. So, if anybody needs some help with this, let's raise your hand, and there's only 3 of us today, but we'll try to get to everybody. So before I do, I'm going to pause the video so you don't have to listen to So I'm going to go to our Create tab, and we want to place a node, one of these points, on this surface, but we want it to be centered on these 2 reference lines, or they're actually reference planes, but we want them centered so that it stays in the center of this mass. So I'm going to go to my level 1 floor plan to place this, and this, when it's highlighted, it draws on whatever face you're kind of hovering over. And so if I'm hovering over this rectangle, it's going to realize that I want to draw on the top of this rectangle, or this square rather. So I'm going to place my point aligned to the center of these 2 reference planes, and it's going to be placed on the top of the extrusion. I'm just going to click once, and if I go back to my 3D view, you can see it's sitting there. And just to make sure that it stays there, we're going to select it. It's a 2-step process, but we can, in its properties, say tell it that we want to show its reference planes itself, because those nodes have reference planes associated to them, and it makes them pretty powerful in what you can do. But so now that's going to show basically all 3 reference planes that it has. So it has like a floor plan reference plane, it has and the 2 vertical reference planes as well. And you can draw on any one of those surfaces. Well, we want to make sure that that stays there, so I want to dimension basically from the reference plane that's like a floor plan reference plane for this to our floor plan reference plane, right? And then make the same parameter, make the dimensional dimension the height, just like we made the height for the square, so, or the rectangle, square, whatever, so that it flexes as well. It stays in the center and it moves up and down as we flex the height of this element. In theory it should, because it's on that plane, but just in case we want to dimension that. So if we go to any one of our elevations, you should be able to see that reference point because we turned on, and its reference planes because we turned on the reference planes in our properties. We use the dimension tool. We can dimension from our level 1 reference plane. If I hover over this guy, I can grab the point, but what I really want is the reference plane that's that's horizontal that's aligned with this top of this plane. So I'm going to tab through until it's highlighted. It's very difficult to see, but it is highlighted there. I'm going to select that and move him out and escape out of the command, and I'm going to select my dimension and I'm going to add my height parameter to that dimension. Now if I change that, it should flex with the object. So now that I'm not plugged in, so it's something. That's why you always want to bring your charger. And a mouse, for that matter. If you haven't gotten a mouse yet to work with Revit, I highly suggest getting a mouse. Yeah.
So do you add a parameter for that dimension, or do you just select height for that parameter?
You can select height for that parameter. Yeah, you can have multiple dimensions function off the same parameter. Not always the best case, but you can. And in this case, it's the best case. You just kind of got to go with it and work. At any rate, getting sidetracked, we're going to draw a circle, a reference circle, and one I'm going to, this screwed me up last class, but I'm going to do it anyways. I'm going to pick that horizontal reference plane as my drawing surface. But then also this placement plane, I want to place it on the point itself, the center of this circle. And down in where, I don't know if you ever notice when you try to do a tool, it kind of says what you're doing down here. And so I want to make sure that I am, in fact, snapping to that reference point. So just going to arbitrarily draw that because the dimension right now doesn't matter. I'm going to define the dimension of it. I'm going to click this little dimension tag here again to make that permanent. And then I'm going to highlight and select the dimension, the radius dimension itself. And I'm going to add a new parameter. And I think on the homework assignment I called it VR for volume radius or something like that. So let's just stick with that, VR. Say OK. Now I want to make sure that one, that flexes and stays in the center. So I'm just going to take that up to 25 feet. That flexes and stays in the center. But I also want to flex my shape to make sure that when I do, the circle stays center to the shape itself. So and it does. Last time it jumped off to the side for me. That was fun. Because I didn't select the reference point as the center point. Thought I did, but I didn't. So now that we know that it's staying in the center when we flex this object and it's flexing itself, we can go ahead and create a void form out of that. And it's going to ask again, do you want to do a plane or a void cylinder? We want to do a void cylinder. And if I select out of it, you can see it's cut a void through here. But it hasn't cut all the way through. And we're going to change our visibility graphics to a wireframe so that we can see this a little bit easier. Last class I didn't show them that and it had some problems, so they were the guinea pigs. You get the benefit of it. So I'm going to tab through until I select that lower plane, and I can grab the vertical Z arrow and I can drag this down until my floor plane reference line lights up in blue, and I know that I'm aligning to that. Okay, and so I should be able to now flex this thing was it 50 feet? It's doing the same thing to me as it did to that one gentleman from earlier today. Oh, and now it's only... Okay. I'm experimenting now because this was giving me problems with another student and I couldn't figure out why it was doing it. I want to see if this works. So actually let's change that to like 200 feet. It still doesn't.
What happens if you have it at below the bottom?
I needed to delete that. It's always something. If you just like do that with it, I think it'll change respectively. Yeah, so if I change this to like 300 feet, I'm pretty sure it moves the whole object up. Okay. There's always complications. I'm going to go ahead and dissolve this and I'm going to delete this guy. I'm going to try this with a model line and see if it makes a difference. This gives me an option to lock this guy. That pretty much solves it for me right there. So if you're having problems with the reference line when you create the void, try doing a model line. Because for some reason it won't allow you to lock this plane if it's a reference line to the floor plan, but if it's a model line, it will allow you to lock it. So let's see if that worked for me. It didn't. It did work for me. Okay, so now that is locked to the bottom plane there. And let's make sure that my hole still flexes. And another problem has arisen.
That's the problem we were having.
Yeah. Well, you're not the only one now. So don't feel bad. You didn't. Got my reference point. See, the host is still saying I can't pick the point afterwards, can I? No. See, this worked for me before when I just did this, right? Keep forgetting to set my parameter. Make sure this whole thing flexes. Okay, everything's flexing right. Cross my fingers. Hope this works. I know it kills me, right? Because I'm asking you guys to do it, and here I can't do it. I did it last class. It's not fair. You have any suggestions? I mean, oh, that definitely doesn't work. Yeah, I spent about an hour with a kid.
What happens when you use the bottom extruded? Same thing.
It's a good question, Clay. Let's give it a shot.
I have a feeling I know what the answer is, but you probably don't even need a point, dude.
Probably don't need a point. See, I think that the issue is trying to get it to snap to the center, though. See? It wants to be there. It just does. Alright, well, I'm going to pause this. Alright, so we have this thing flexing. It's working properly. It's cutting through. I did not do anything significantly different than what I showed you. Create a reference line that's a circle. The center of it should be on this node, this dot, and make sure that it says reference point as the host of that circle. And then I created, selected it and did a create void, and then pulled the lower plane of the void down till the reference one, or level 1 reference plane was highlighted, so I knew that it attached and locked to it. Okay, and that is locked to the reference plane level 1. The top of it is locked to the top of the extrusion, and so in theory it should now flex with the object. That was like perfectly timed too. Okay, so now our next step is we want like 4 or 5 of these, and we want them all different sizes, right? So we're going to use our family types in order to create multiple sizes of this object. So just going to name the first one type 1, and 100 feet, 100 feet, height is 50 feet, sorry, and the width is 100 feet, and our radius, it will be 25 feet. Okay, so that's type 1. We create another new family and change our parameters. So length is 50 feet, width will be 50 feet, height is 25 feet, and our radius is 15 feet. So now we have 2 separate family types. We have 2 different sizes, right? And we want to create one more for the moment, and we want to label this 1 inch by 1 inch by 1 inch, and our radius will be 0.25 of an inch. Press apply. Okay. I'm going to change my viewport to being 1:1 so my dimensions don't smother this guy. But you can see we've got, no, you can't see it. Never mind. Scroll in here and highlight something. What? There we go. You can see we've got the hole cutting through it, and it's a very small object. It's 1 inch by 1 inch by 1 inch square. This object you will be cutting out in the 3D printer. The assignment is up on Blackboard, and it's due on the 18th. So you've got 3 weeks to do this. What's that? This one part of the assignment, which is a 3D printed version of this 1 inch by 1 inch by 1 inch square. Yeah. This is in-class assignment 2. The 3D printing part is in-class assignment 2. The rest of it's still due on Thursday. Okay. Just wanted to clarify that. Yes. Down here in your viewport graphics here, you can change the scale to being 12 inches is equals a foot, which is 1:1.
Oh, I was just gonna ask, you said this is assignment 2 and it's due Thursday. Did you mean it's assignment, like in-class assignment 3 due Thursday? Because that's what you're saying this is. In-class assignment 3 and whatever.
Does it?
Yeah.
I got really confused when I had to change the numbers around. I want to believe you. I really do. I'm going to check it right now. Assignments. No, in-class assignment 2. So you have assignment 1, which is this exercise that we just went through, right? Creating 4 different family types. The next family type will be adding a parameter, so L equals W, W equals 25, H equals L divided by 2, and the radius equals L divided by 3. Excuse me. But aside from that, this in-class assignment 2 is opening up that parametric mass, grabbing your family type 1 inch by 1 inch by 1 inch, and exporting it as a 3D STL file, and then taking that to J and having it printed out. And I'm giving you guys till the 18th. So on the 18th, that night, you'll want it sitting on the desk to get your points. Okay? That little clarify it a little bit better? Okay. So, does everybody have access to the S drive? Did anybody do that this weekend? I heard a try. That's a start. Okay. So, your next mission, in order to get the add-in STL exporter, is to get onto the S drive. And let's go back to this web page and go to handouts, S drive. we want to join your computer to the Active Directory. Can create new second folders. Why don't they ever make this easy? This is the link that he gave me. Mounting the UNS drive on a Windows or XP computer. I just need to read. If you follow these directions word for word, you should be able to access the S drive, which becomes a drive on your computer, and you have to sign into it with your Vandal ID and password. And follow the link CAA to architecture downloads, classes, architecture. It's kind of crazy, but that's the way they wanted it. Architecture 244. There is an STL exporter for Revit for 2015. If you don't have 2015 or you don't want to go through this process, you can also Google XTL exporter for Revit 2015, 2014, whatever version you have, and you can download it and install it from the internet. It's a free download. Just make sure that you're downloading it from an accredited site and you're not downloading some wacky Trojan virus or something. Okay, so I was trying to be helpful by giving it to everybody, but that means getting on the S drive or passing a thumb drive around, which I don't particularly want to do. So that's where it is. You can also get it online by Googling it.
Or studio computers.
Or Studio Computers have it.
Actually, I think all the campus computers are connected to the S drive already.
Good point. So you could log in to one of the Studio Computers, access the S drive, put this on a flash drive, and then install it on your computer. And then put it on your... Now this is this is kind of the steps for removing and using the 3D printer, because you'll have to like vacuum out all the excess powder, and there's kind of just a list of steps that Jay likes people to go through. So before you go in there, make sure you've read through that and kind of have an understanding of that, so he's not bombarded with 60 questions from 60 individuals. You're 30 of them. The other class is going to do this as well. Any rate, what I'd like to do, since I have it installed, is show you the proper procedure for exporting, and it'll be on the video tutorial so you can see it. So basically, we have our shape, we're in the 3D viewport, and we've got our viewport set to 1:1. I'm going to just go ahead and click the STL exporter for Revit, and in the Generals tab, we want to make sure that the binary is selected and the units are decimal inches. And the reason why is because the software that Jay uses to read your files reads in decimal inches, and I've had issues with, if I didn't set it to decimal inches, that it doesn't come in the proper size. It comes in like 0.83 of an inch. It's very odd, but anyways, so binary format and decimal inches as the units. Categories are grayed out. You can't select them because there aren't any categories actually except for masses in this conceptual mass environment. So it doesn't let you choose. But when you do export a part from your project in the future, I just leave them all checked. I wouldn't worry about it. Click save, asks you to save it, put it somewhere on a flash drive that you can take it into Jay, and then he can get it off there. But save it as an STL file type. And I'm not going to save it. So that's it. And we've got 10 minutes left. Woohoo! Does anybody want to... Oh, I can show you guys. So in the formula tab is where you're going to type in your formula. So I'm going to create a new type, and so height, what did I say here? Height equals L, caps lock, L divided by 2. L equals W. VR equals L divided by 3. And width is what we want to change. So let's just say 25 feet. And it disappears because it's 1-to-1. I'm hoping. It's just, yeah, okay, good. So now the funny thing about this is once you start defining parameter or formulas, if you go back to your type 1, the formula is still there, right? So when you defined your W equals 25 feet, whatever you defined your W as, like, actually that sucks. I'm sorry to say that, but at any rate, it gives you a basic idea of what the formula, how formulas work. And
So really, those other three don't matter.
they don't matter at this point. No, that sucks. So just make one. I guess just make one type with the formula, and when you export, L equals 1, or L divided by 1, right? Now we're back to that, yeah. So, make one type. Formulas are more important than multiple family types of this particular object. It's always fun the first time teaching this and figuring that we didn't get to this last class. So they're going to be in a world of surprise. And I'm going to get a lot of angry emails. At any rate, so go ahead and set the formula up, and just note before you export it as an STL file, you'll want to change your height formula to L divided by 1 so that it's equal to 1 inch by 1 inch by 1 inch. Does that make some sense? Good.
So we're still creating the 4 different silos, just using the formula instead of the family type?
I'm not so sure it's going to work.
just don't go back and switch it.
Yeah, so if I create a new family type, change the formula. Doesn't work. That's a bummer. That needs to be fixed in the next version. I will. I'll send them an email. So that is basically it for the class. I was going to jump into drawing some larger masses, but if you guys would rather have us answer some questions about this for the last 5 minutes, we can do that.
So how does that affect the assignment, I guess, is my question.
Yeah.
One thing don't matter.
So it affects the assignment in the sense that you're not going to create, there's no point in creating 4 separate family types. Just create one family type and use the formula, because it's important to understand how you can start to create simple formulas so that you only change one and they all change. It's also important to know that you can make multiple family types within the same file, but I think the formulas are more important at this point. We've seen how in a 2D form of this we can make multiple families, right? So kind of seen that side of it. Let's check out the formula side now. Okay.
So when we go to do the 3D printing, so we'll just have to delete the formulas out and then make it.
Okay, so figured out a little bit of what was going on with the family types and the formulas. If you constrain, if you use the formula and constrain all 4 to a particular dimension, it grays these out. And so when you go to change to family 2 and press apply, it doesn't, it changes to these amounts. So if you leave this blank, whichever one you're referencing, so if you, so W basically, L is equal to W, and then these are equal to L divided by 2 and L divided by 3. Now we can start changing the width here, and so for the type 2 we want the width to be 50, and I can press apply, and now you notice my length changes to 50, my height to 25, and my VR to 16 feet 8 inches, which is close enough to 15 feet. And if we go back to our type 1 and press apply, our shape flexes because it's no longer constrained, and these aren't grayed out. So type 1 is 100 feet, the width is 100 feet, the height is 50 feet, and the VR is 33 feet 4 inches, which is similar to enough to 25 feet. So you can go to family 3, and we want this to be 1 inch. Press apply, and now that family type is 1 inch by 1 inch by half an inch height. So if we go back to family 1, the formula should start to work for all family types. So for the homework assignment, part 2 of assignment 1, I want you guys to create 4 family types, as shown here. Type 1, height is 50 feet, length is 100 feet, width is 100 feet. Type 2, height is 25 feet, length is 50 feet, width is 50 feet. And then type 3 is going to be your 1 inch by 1 inch by 1 inch. And you notice that my height is half an inch. We're going to leave this for the homework assignment that you're going to turn in Thursday. Leave it at L equals 2 for the formula. But when you go to do your 3D print, change that to L divided by 1. Okay? And then the formulas will now spit out that height equals 1 inch, length equals 1 inch, and width equals 1 inch. And that doesn't affect your other family types. So, well, it affects the other family types in the sense that L divided by 1, it's going to pick up that formula. So when you turn it in for the homework assignment on Thursday night, height formula should be L over 2. The length formula should be W equals W. And the volume radius equals L divided by 3. And you should have 4 different family types. One where W equals 100. Family type 2, W equals 50. Family type 3, W equals 1 inch. And family type 4, W equals 25. And it should flex when I hit apply. And hopefully everyone will go back and watch the video and they will get this right. So what we were screwing up was we were putting too much constraint on the formulas. So leave the W formula because we're referencing the W is kind of our what we want to change. We leave that formula blank. And all these other formulas are based off of the width formula. So that concludes the video for tonight. And that's it. So hopefully everybody gets that worked out.